In the previous class, we have seen about the fundamentals of plant layout. That means definition, objectives, and principles of a plant layout we have seen, and classification also we have seen. Process layout, product layout, combination layout, group layout, and fixed position layout. Advantages of each and limitations of all the layouts we have seen. We will see the layout design procedures. While discussing about the process and product layout, we have seen the differences also. Next, we will see selection, specification, and implementation of plant layouts. Plant layout is nothing but the manufacturing or production plant where we will convert the raw materials into the finished products, which consists of various departments, work centers, and machinery or equipment. We are arranging these facilities in the manufacturing plant. The general definition is it is a plan of optimal arrangement of facilities, including human resources or personnel, operating equipment, storage space, material handling equipment, and all other supporting services, and also along with the design of the base structure. This is the definition of the plant layout. The various objectives are in order to fulfill the objective, that is to convert the raw materials into finished products with the minimum cost. We have to make all the other facilities and other supporting services in the effective way, so that we can have maximum production within the limited time, so that we can increase the production of productivity. And next, the principles are principle of integration, integrating all the resources. Principle of minimum distance, the minimum distance from one equipment to another equipment, so that travel time will be reduced. Cubic space integration, utilizing the length, width, and height also. That is the third dimension. Principle of flow, we have to move in the forward direction, no backward direction, so that time will be reduced. Principle of minimum handling, minimum flexibility, maximum flexibility. So if there is any change in the demand, so that we have to rearrange the facilities. And principle of safety, security, and satisfaction of the workers. And the principle of minimum handling, that is we have to reduce the distance travel of the materials. Classification of layouts, process and product layout, combination layout, fixed position, group layout. In the process layout, we are arranging the equipment in such a way, or grouping the machineries of similar kind, so that different products, according to their operation, they will be moving from one area to another area within the layout. Milling machines are one side, lathe machines are one side, assembly line, welding, all types of welding, grinding, inspection, shipping and receiving, and painting. These all are at different locations, but depending upon the operation of the product sequence, it will be moving from one place to another place. This is the product layout. Suppose this is, for example, for a particular product, it has to perform turning operations first, then milling, and then drilling. Next to going for the assembly, and then inspection. Next going for the package, and then dispatch. This is for one product. So that to perform these operations, this machinery is or the machining equipment will be arranged in this sequence, so that product will enter here and then it completes its operations, and it will be dispatched. This is about the product layout. Next coming is combination layout. Here we can have two layouts, that is the process layout and product layout. When you see here, F is for forging hammer. All forging are arranged in one place. Next is hobby machine, H. These are arranged in one place. If you see process layout, it is vertical. So here all forging are one place, hobbing at one place, heat treatment at one place, and gear finishing at one place. We see vertically, it is a process layout. Suppose the product enters from here, forging, and then hobbing, heat treatment, and gear finishing. This is for one product, and for another product, the sequence may differ. If you see horizontally, this will be looking like a product layout. So this is a combination layout, combination of process layout and product layout. Next is fixed position layout. Here the material, labor, and equipment will be coming to one place. You suppose the product is very big, like shipbuilding or aeroplane or satellite making. All the materials, labor, and equipment should be coming to that place, and should be converted into finished product at that place only, so that product movement is not possible sometimes. So we are making the ship or aeroplane or a satellite within that area only and converting into the finished product. This is example for the fixed position layout. Next is the group layout. As we have seen in CAD/CAM, we are clustering the components based upon its characteristics, so that we have the group of products. Suppose this is one group, W, X, Y, Z are the components. On the one, that is milling, W and Y components are going to get operated, and second is the drilling. W, X, Y, Z components are going to get operated, and on 3, soldering, X and Z components, and 4, grinding. Y component is operated, and next 5, W, Y, Z components are getting operated, that is polishing. So here W, X, Y, Z are the components. Similarly, other components also will be there. This is one group. In this group, the components, 4 components will be entering and getting operated to convert into the finished product. This is the example for the group layout or the cellular layout. Any doubts in the classification? Process, product, combination, fixed position layout, and group layout. Anything you want to discuss? In the last class, I have recorded the video of this. You can have the look of that. Have you seen that? If you want to discuss, I will discuss this. Otherwise, I will go for the next topic. Next is plan layout design procedure. If you want me to repeat, I will repeat this. Otherwise, I will go for fixed position layout, and that is design procedure. Shall we go for the design process? Akash, Akshawardhan. Shall we discuss this? Aryan? Are you listening or not? Varun? Okay, I am starting the design process. Here we have to formulate the problem, analyze the problem, search for the alternative solutions. That is the start step. And fourth one is evaluate the design alternatives, select the preferred design, and specify the solutions. These are the 6 steps in general. What is the problem we have to see first in order to go for the plant layout? Whatever facilities are there, we have to take care, and then we have to analyze those problems for which product we are going to make the layout, and any other alternative solutions are there, we have to see that, and then evaluate the design alternatives. Then we go for the preferred design and then specify the solutions for that. This is the design process in general. Next, what is the plant layout design consists of design process? First one is formulate the layout design. What is the problem? We have to identify that and then analyze the design problem. Next is searching for the alternative layout design, alternative layout designs. Next is evaluating the layout design alternatives. Next is selecting the preferred design. And next is specifying the layout design to be installed. First we have to formulate the design problem. Next we have to analyze it. Next we have to search for the alternative design. Next, to evaluate that, next we have to select the preferred design, and we have to go for the installation next. This is the plant layout design process, and what are the communication links among the products, schedule and layout design. They are interlinked to one another. Objectives we have seen earlier, but we will see again once. What are the main objectives of making a further plant layout are: minimize investment in equipment, minimize overall production time, what are the investment we are making for the machinery or the equipment, we have to reduce that. Next is overall production time we have to reduce. We can go for the straight line flow so that the distance will be reduced. To utilize the existing space most effectively, that is length, width and height also we can utilize, that is the cubic space. Next, provide for employee convenience, safety and comfort as we have seen in the principles. Next, maintain the flexibility of arrangement and operation so that if there is any increase in the demand also, we have to rearrange that. Next, minimize material handling cost, that is cost for the movement of materials from one place to another place. Next, minimize variation in types of material handling equipment. We have various types of material handling equipment. We can choose which equipment is best suitable for the plant. Facilitate the manufacturing process. And next is facilitate the organizational structure. These are the objectives. Next, we will go for the layout design procedure one by one. We have 4 types. First one is an Adler's ideal system approach, the most basic steps, Apple's plant layout procedure, and Reed's plant layout procedure. These are the various layout design procedures. First, we will see Adler's ideal system approach. This approach is, you can see here, aim for the theoretical ideal system that you can see in the apex position. Next is to conceptualize the ultimate design system, ultimate ideal system. That is the second. Next is design the technologically workable ideal system that you can see here. Next is install the recommended system and present the system. These are the layout design procedure for the Nadler's ideal system approach. First is aim for the theoretical ideal system. Next is conceptualize the ultimate ideal system. Next is design the technologically workable ideal system. And last is install the recommended system. That we can see in this hierarchy, ideal system hierarchy, theoretical ideal system, next ultimate ideal system, technologically workable ideal system, and recommend the system and present system. Next, Immense basic steps for analysis and layout problem. Whatever we have seen initially, 6 steps, we are increasing those steps. If you see, put the problem on paper, show lines of flow, convert the flow lines to machine lines. These are the basic steps. Next, what is meant by good plant layout? That is placing the right equipment coupled with the right method in the right place to permit the processing of a product unit in the most effective manner through the shortest possible distance and in the shortest possible time. These are the consisting in the good plant layout. First, we have to choose the right equipment and place it. We have to choose the right method in the right place and to permit the processing of the product unit in the most effective manner. Which method or processing method is best suitable for that, and through the shortest possible distance and in the shortest possible time. These are in the choosing the good plant layout, and the importance of good layout as a factor in the ensuring low cost production is thus well established and its need is well understood. So, while designing the plant layout, we have to consider these steps, and what is meant by good plant layout we can see in these 6 points. Next is Apple's plant layout procedure. We have seen 2, and this is the third one. Apple's plant layout procedure. Here we have to procure the basic data to identify the problem or to frame the problem. Next, analyzing the basic data, whatever is given. Suppose you are making some product. What are the data that is required in machinery, equipment, or other facilities? And the next, we have to analyze those data. Next, design the productive process. That is the process we have to identify. Next is the plan the material flow pattern. How it should move from one place to another place or from one machinery to another machinery. Next is consider the general material handling plan. Next, to calculate the equipment requirements. These are the 6 steps in plant layout procedure. Next, second step is plan individual workstations and select a specific material handling equipment. Next is coordinate groups of related operations, design activity relationships, determine storage requirements, plan service and auxiliary activities, determine space requirements, allocate activities to total space, consider building types, construct master layouts, evaluate, adjust, and check the layout with the appropriate persons. That is persons who are working with us, and obtain approvals from the superiors, install the layout, and follow up on implementation of the layout. These are the 20 steps in the Apple's layout design procedure. I will repeat again. Procure the basic data to frame the problem. Analyze the basic data. design the productive process. You have to plan the process flow, plan the material flow pattern, consider the general material handling plan, how the material handling should be taking place, calculate the equipment requirements. It can be material handling equipment or machinery, and plan individual workstations. Next is select the specific material handling equipment. Next is to coordinate groups of related operations. Design activity relationships. Determine storage requirements. Next, plan for service and auxiliary activities. Determine space requirements for all the work centers, machinery, and the material handling. That is the facilities available. Next is allocate the activities to total space. What are the operations that are going on? Consider the building types. That is the structure in which we have allocated the facilities. Next is construct the master layout. Next is to evaluate, adjust, and check the layout with the appropriate persons. Those who are working with us or within the department, and with other departments, we have to evaluate those designs. Next is to obtain the approval from the superiors. Next, going for the installation and implementation of the layout. These are the various steps in Apple's layout design procedure. Next is the REAST plan layout procedure. In planning for and preparing for the layout, we recommended the following steps to be taken in a systematic plan of attacks. That is, for making the plant for production activity or any other purpose, we have to follow these steps according to the data. The process or the procedure, we have to analyze the produce or process to be produced. What is the product that we are making? We have to plan the process and analyze it. Determine the process required to manufacture the product. Prepare layout, planning charts. We have to prepare the layout planning charts. And next is to determine the workstations. Analyze the storage area requirements. What are the requirements of the storage area? What is the amount of space required, and what are the materials to be placed? This is regarding inventory also, the storage of raw materials, and establish the minimum axial width. That is, axial is nothing but the space between the one rack or another rack. That is the movement for the material handling equipment to move in between, or movement of the human also in between the storage area. Establish office requirements of different departments. Consider personal activities, personal facilities, and services within the work center, and survey plant services. What are the plant services it is providing? We have to look on that. Next is to provide for future expansion. If any demand is more, we can go for the future expansion in order to serve better. The plant layout planning chart incorporates the following operations. Initially, we have seen layout planning charts here. We have to prepare the layout planning chart. This layout planning chart contains about the operations, transportation, storage and inspection, standard times for each work element, machine selection and balance, labor selection and balance, and material handling equipment. These are some of the layout planning tasks. Next is according to the PB Mahapatra textbook, layout of physical facilities. That is also same. In this diagram you see, we have seen layout design procedures, and before that we have seen the classification of process layout and product layout. This is process layout. The diagram here we can see receipt or the reception. This is at one place, one area. The area is allocated for that, and here is shipping. The entry of products will be from here, and here various lathe machines are placed, milling machines are placed, grinding, drilling, painting, inspection. So as we see various arrows, the flow of the product you can see here. This is for one product, this is for second, and this is for third. This first one is moving from reception to the lathe and then milling. First it is milling and then lathe, grinding, painting, and then going out. Second one is first it is going to the lathe, next drilling, next grinding, next painting, and then going out. It is not going for milling. Second product. Next third one. First it is going for the lathe, and then drilling, then milling, then painting. It is not moving to grinding. Next it is going out. This is the material flow in the process layout for three different products. It will be changing from product to product, but equipment or machinery arrangement is according to the process it is going to perform. So lathe machines are at one place, drilling are at one place, painting one place, grinding one place, and milling one place, and inspection at one place, reception and shipping at one place. Here you can see the product layout. This is one product. This is one product. This is for one other product. This is one for another product. So it will be moving according to the operation that is required. Suppose for this product only two are required, two operations. For this another two operations, and for this another two operations. So the equipment arranged in this way. We will see the selection, specification, and implementation in the next class.